Alright, now we'll talk about permutations. Permutation is an ordered arrangement of items that occurs when no item is used more than once. The order of our arrangements make a difference. The book may say order matters, order is important. And some examples of that you may see in the homework are things like the results of a race, first, second, third, order of performers or jokes, a club choosing officers like president, vice president, treasurer, and a unique arrangement of letters in a word. So, first one we're going to look at is actually one we could use the fundamental counting principle on, so we're going to start with that. Okay, so a comedian has 5 jokes to present during an open mic night, so we'll do 5 blanks. So that first joke, second joke, third joke, fourth joke, fifth joke. And you're not going to tell the same joke more than once if you're doing a set. So that means for the first joke, he has 5 options. Once he does that first joke, he now only has 4. And you see this pattern. And then he has 3, and then he has 2 left, and for his last joke, he's only got 1 left. So we can type this in the calculator. 5 times 4 times 3 times 2 times 1 is 120. So you may notice that pattern of numbers here. So it turns out that this pattern of multiplying a number by all the smaller numbers down through 1, because there's an infinite number of small numbers, but all the numbers down through 1 has a name, and it is factorial. Okay. So, for example, what we just did here, 5 times 4 times 3 times 2 times 1 is equal to 5 factorial. Almost looks like one line here, so 5 factorial. Okay, so that is read. Factorial. Alright, so I guess it's a good idea to give you the official definition. I like to learn this together, so I usually don't put that in my class notes. But in general, for a positive integer, we'll say n, positive integer n, the notation n factorial, read as n factorial, is the product of all positive integers down through 1 and by definition 0 factorial is 1 as well. Okay. All right, so along the same lines of this, I want to mention a few other things. What happens if we do the following? I just want to show you. So an easy example. Here is 15 factorial. Of course, what I haven't mentioned is we can type this into the calculator. I could use this one as an example. In fact, I'll do that real quick, but whenever I work this one out for you, I'll show you the steps. I'll go ahead and show you the steps on this one. So 5 times 4 times 3 times 2 times 1, we know that's 120, but also if I type this in the calculator, so 5, so I'll just write the steps down here. Steps to type in the calculator. So first you're going to type in N. In this case, N is 5, so we'll do 5. And then I have to go to the PRB button. So I'll click the PRB button. And then I'm going to kind of scroll over to the exclamation mark. Okay, so we have 5 factorial, and there it is, 120. So I guess the last thing is you would choose enter. Okay, so we'll do the same thing down here, because I really don't want to type 15 times 14 times 13 all the way down. So 15 factorial, if I type that in, use my steps. Notice on this one, we end up with something weird. That's 1.30767, 1.307674368 times 10 to the 12th. What does that even mean? Okay. What that means is this is scientific notation. And if I want to convert that, I'll show you how to do it. First of all, some of the homework will say use scientific notation. If it does, so if my math lab wants scientific notation, you're going to use the multiplication symbol X, not the letter X. Okay, just make a note of that. You'll see what I'm talking about when you work it, you get it wrong, and you say, what did I do? Look at that note. There's a toolbar, and that'll show you, that'll do it for you. So if you have to convert it, or even if you don't have to convert these, I want to show you what this actually means, what this number really looks like. So I'm going to write this down. I'm going to put my decimal real small. 307,674,368. I'm going to add some zeros here. You can add as many as you want. If you don't add enough, you can add more. If we have 10 to the 12th, that means we're going to move our decimal 12 units to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have just enough. I don't need that last 0, but that's where my new decimal is, right there. So that's 13073836836. Okay. And I have how many zeros? 3 zeros that count. That's a decimal. So this number is huge. That's 1,000, that's million, billion, no, I'm wrong, 1,000 million billion trillion. So it's 1,307,674,368,000. So that's a huge number. They may want it in this form, they may want it in that form. Okay. Sometimes if the numbers are too large, you'll get an overflow error. So let me just write that real quick. If the number is too big, you get an overflow error. Okay, we're going to see what that looks like. Overflow error. So, if I were to try 100 factorial, you get the overflow error. And I mention that because in the next example, in fact, we're going to have two examples right here. In this second example, if I type that in directly, I get an overflow error. And I'm going to kind of work these interchangeably, so I'll work the first one first, but just to mention this, if you type this second one in, into the calculator, you get an overflow error. Okay. So what I'm going to do for you is we're going to use example 1. I'm going to show you how to work that in the calculator. And then I'll show you an alternate way we can work number 1, which is going to help us with number 2. Okay. I like to look at smaller numbers first. So this first one, you can type this in directly to the calculator. So let's do that first one. Like I said, I like to be careful with parentheses. So 16 factorial, parentheses, divided by 12 factorial, parentheses. These parentheses may be redundant, but if I'm taking a test, I don't want it to read the wrong thing. So this is 43680. Now, like I said, if I type the second one in directly, 684 factorial, parentheses, divided by 682 factorial, I get that overflow error because the calculator is trying to do 684 factorial first, which it can't do, so we have to help it out. So let me show you the process using this easy example. Okay. So 16 factorial over 12 factorial. We already know that 16 factorial is 16 times 15 times 14 times 13 times 12 times 11 times 10 times whatever. All the way down to 3 times 2 times 1. In math, if we have a pattern that's pretty obvious, a lot of times we'll just do these ellipses. We'll do the same thing with 12. 12 times 11 times 10, well, you get the picture. So you should be noticing that everything under the 12, including the 12, is going to cancel out. Right? So we end up with 16 times 15 times 14 times 13. And if I type that into the calculator, I hope I get 43680. 680. 16 times 15 times 14 times 13, 4,360 feet. So it works. Of course, if it works for one example, it doesn't mean it works every time. But I feel like in order to convince you it's going to work here, I wanted to show you that easier one. Well, let's do that on this one. 684 factorial over 682 factorial. That's 684 times 683 times 682. All the way down, 681. We don't have to do very many. In fact, you probably recognize, since this is 682 factorial, then the 682s will cancel and everything else. So 682 times 681 all the way down to 321. Usually students like to see that. These are going to cancel. So we end up with only 684 times 683, and that is equal to 684 times 683, 467.72. All right, so that will do it for factorials. We need that information in order to understand the next thing that we're going to talk about, which will be permutations. All right, so moving on to permutations, and the formula, the precise formula, here as follows. The number of possible permutations if r items are taken n at a time is NPR equals n factorial over n minus r factorial ways. Don't worry so much about this formula. You will need to memorize the formula, but when we actually work the problems out, we have some easier methods, okay? What I'm going to do for you is I'm going to show you how to do this on the calculator. Before I do, let me mention that we have any of these permutation problems can also be done as fundamental counting principle problems. All right, so there's our formula. NPR, n factorial, n minus r factorial. All right, so let's do this one. It says first, or do it by hand and the calculator. So by calculator. And then over here, I'll do it by hand. And when I say by hand, we're going to use the formula. All right, so the first thing we have to do is establish what n is and what r is. Okay, here's n. This guy is n. This guy is r. 7, 5. So on the calculator, to type this in, the first thing we do is we're going to type in. Okay, I'll do that in red. N is 7. Almost got it wrong. N is 7. Okay, so we type that. And then we'll do PRB button. PRB. All right, we'll scroll. Here we have NPR. Okay, and then we're going to type in R, which in this case, of course, R is 5. So it's going to look like, on the calculator, it looks like 7 NPR 5. All right, and you get 2520. So let me do it by hand. What I mean by hand is using this formula. Like I said, You can use the calculator to do these, so there's almost no need to do these formulas by hand unless you just want to check. All right, so 7p5, this is probably the only time I'll use the formula because I have the calculator at hand and there's really no reason to do it by hand unless you just want to check. Okay. So 7 factorial over 7 minus 5 factorial. You could type this in directly to the calculator. If you want to clean it up some, you can, but 7 factorial divided by 7 minus 5, and then put the factorial, 2520. You could do that. Of course, if you want to do it completely by hand, I guess we could just do that. That's 2 factorial. I'm still probably going to want to use my calculator because that's going to be 7 times 6 times 5 times 4 times 3. I don't really want to have to do 5 numbers like that by hand. So I'm still going to end up using the calculator regardless, right? So there you go. But you do need to get familiar with the formula in case you see it on a homework or test question. So let's do this example on this page, and then we'll have one more after that, I believe. All right, so a club with 13 members is to choose 3 officers, a president, vice president, secretary, treasurer. If each office is to be held by one person and no person can hold more than one office, how many ways can we do this? So we have 13 members. That's our N because that's the total amount. We have president, vice president, secretary, treasurer. Those are 3 titles, all distinct. And so now we can just plug that in the formula. 13PR. I'm sorry, 13P3. Okay. 13 NPR 3. Notice, going back real quick. Notice there's an NPR and an NCR. We're going to talk about NCR later, but they are different. Okay, 17, 16. Now, it's not always the case that the biggest number is your R or your N. Sometimes you have to do a little work. Same thing with the smaller numbers, not always the smallest thing here. And you're going to see some examples where things change. You may also be recognizing that this could be a permutation. We use the permutation formula. I could have also done, treated it like a blank problem. Like we said earlier, any of these could be done as blank problems. They're not always easy as blank problems. If there's any hesitancy, I would just always do what you recognize first. So if I treat it like a blank problem, we have the 13 members. I'll come back to that. But the 3 positions we have is president, vice president, and secretary treasurer. If we have 13 members, then we could first choose any of those 13 to be our president. And then we have 12 that could be vice president, 11 that could be secretary treasurer. So I'm hoping that when I type this in, I also get 17, 16. And there we go. Okay. So you could work these both ways on a test just to make sure that you get it correct. And we got one last one that we're going to talk about. It is the number of permutations in items where P items are identical, Q are identical, etc., etc., etc. Okay. So this is a tricky one. I'm going to use a little bit of different notation here, but that's what's in the homework, so I like to keep things the same in the notes. But you're going to see this type of problem Could be worked out with letters in a word, what we're doing now, digits in a number. There's a flag problem in the homework I've seen. That's like you have red, white, and blue triangular flags on a pole. How many distinct ways can you do that? So I just wanted you to know it's all basically the same question. So in how many distinct ways can the letters of the word Mississippi be arranged? First, let me indicate what I mean by distinct. So here we have M-I-S-S-I-S-S-I. Let me do it this way. I'll put the first P as red and the second P as black. So this versus this, these are not distinct. Okay. It's the same, I mean, I was making it simple because it still spells Mississippi, but this is the same thing. Okay, I put the first B here, it doesn't change the word. Distinct is things like this. M, let's put some S's here, put the I's together, and we got the other two S's. We got another P, P, I think. Okay, that's distinct from Mississippi. Or if I put, something like this, with the two I's first, and M, S, S, I, S, S, P, P, that's distinct. These are distinct. Okay, that's the idea. So, the way we're going to work it is the number of things is n. So the total number of letters or digits or flags is our n. Okay, so in this case, n is 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So n is 11. And then we have to find the repeats. Okay, so I'm going to deviate from that a little bit because the number of P's and Q's or P's, that could be confusing. So now we need to find the repeating letters. Okay, what I mean by that is I start off, I'll just rewrite the word, M-I-S-S-I-S-S-I-P-P-I. So, you may find this helpful, maybe not. I'll start with the first letter, none of the M's, there's only one M, so nothing repeats. The next letter I get to is I's. Of course, there's some I's that repeat. 1, 2, 3, 4. So the number of I's is 4. And I'm going to highlight these as I go. You could circle them or cross them out. All right, the next letter I get to is S. The number of S's is 4. And then number of P's is 2. Number of P's is 2. All right. The good news is the questions you'll have in the homework I don't think are as complicated as this. But because they're less complicated, I needed to show you a harder one, otherwise you could get something confused. And what I mean by that is the following. We're going to set up n factorial over n sub I factorial. Don't worry if you don't like all the subscripts. You can just look at this and then write it down. This is multiplication. Oops, that's not multiplication. We're going to multiply these guys together. Okay, so we're going to multiply the number of I's, maybe I'll do it this way, the number of S's factorial and the number of P's factorial. Okay. So, the total n, that was 11, so 11 factorial. The number of I's, remember, is 4 factorial. The number of S's is 4 factorial. and P is 2 factorial. The reason I'm using a larger number here is because in the homework I've seen some of them are like all 2 factorial. Well, what is 2 factorial? 2 factorial is 2. So you might get confused and think that whatever the number is here, I put down here. But it's actually the factorial. So what I do is I like to do the bottom first, and then I'll put it together. The reason why is if you're not careful with parentheses, it will read the wrong thing. And when I do this in class, in a classroom setting, we often have that discussion. Somebody types it in incorrectly, so we like to see it. So let me just do the bottom first, because I cannot make there's no way to make mistakes with the parentheses. Okay, so that's 1152. And now it's easy to do 11 factorial over the number we just had, 1152. 34650. Okay, so that will do it for this section.